Okay, guys, once again, I welcome you to my lesson for today, where we'll be looking at a chapter called Analytical Geometry. I hope it's going to be an interesting lesson. Guys, please do allow me to say it's very much important, guys, that I say it's very, very much important because what I'm about to say, it's massively important, guys. A day without learning something new, it's a day wasted. By so saying, please make sure that by the end of each and every lesson that I conduct, you learn something new. So guys, before I start with the lesson for today, can I just get an indication from one of you guys if you are able to hear me when I speak? And again, can you see on the board?
Yes, sir.
Yes, sir. We can see and we can hear you.
Yes, sir.
Okay, 100%. Just make sure that as soon as you're done making a comment, you mute your mic. So, Zimi, Moru, who are these two guys? I'm just going to mute the mic from my side because I've asked my assistant to send a reminder. So just make sure that all of you guys have got your mics muted. So I'm going to flow with the lesson without taking any comments until I get to the end of where I need to be. So I hope everyone is going to control their mics from their side. So ladies and gentlemen, in today's lesson, we'll be looking at analytical geometry. So I suppose everyone who has joined this lesson is in grade 10, 11, and 12. And again, I suppose you are ready for today's lesson. And most importantly, guys, in case if you are upgrading your mathematics, this lesson is also suitable for you. So just make sure, if necessary, you can write down the notes, but otherwise you don't need to. All you can do is just to make sure that if you copy down the notes that I send in the group, you can refer to those notes. But there's no need for you guys to be writing. So in today's lesson, guys, we'll be looking at a bit of revision for grade 10, where we look at the distance, the midpoint, and again, the gradient. So that means if you're in grade 10, you should be familiar with the formulas for calculating those. And again, you should have an idea of how to calculate those. If it's something new, I'm going to make sure that you fully understand how to calculate those. Guys, somewhere in the middle of our lesson, I want to talk a little bit more about inclination of a line. Very, very much important, ladies and gentlemen, that you are aware of that. Let's say inclination of a line. Guys, make sure that you've got your mics muted. Otherwise, I'm going to mute it from my side. So let me just quickly check some Kelo Innocent. Okay. So guys, it doesn't end there. As we continue, we should also talk about equation of a straight line. So a equation of a straight line. So this is some of the information that you can write down to say, by the end of this lesson, I should be able to make ticks on each of those to say, we've covered those and I understood what is meant by those. So I just want to make you guys aware of something. Mathematics, physical sciences, life sciences, and geography, those subjects are not really difficult, guys, and never ever blame yourself when you get lower marks on those subjects. The reason to that is because your approach or the strategy that you use to study, it's not relevant. So at all times, guys, just make sure that when you prepare yourself, you don't just study. There's a strategy that you must use when you study. I think I should make a very special video where I cover all of that, just so that you understand how to study, or the best approach to apply when you want to study. Because normally what happens is you guys just open a textbook, and then from there you just read and read and read and read, but not following the correct procedure. So I want to prove it to you today that it's not really difficult to study, guys, especially if you're studying by your own. What you can do is to make sure that you attend that one masterclass lesson. From there, you study on your own. I'm telling you, if you can learn how to study by yourself, when you get to varsity, you will find varsity very easy. You will get as many distinctions as you can. Why? Because you are able to study on your own. You do not fully rely on your teacher to teach you. So, good people, as we continue, of which I assume it's something that we can cover on our next lesson. That is what we call the application involving quadrilateral. So all of this I've sent in the group. So just make sure that for each and every topic that we cover, you fully understand. Quickly, we can just go through what I've indicated as part of a bit of a revision for grade 10. I think, yes, it's a revision for grade 10 learners. So remember, guys, in grade 10, they introduced you to a distance. What is distance, guys? So distance is the same thing as the length. So the moment we talk about distance, it means we want to know the length between 2 points. Very, very much important, ladies and gentlemen. From point A to point B, what is that distance? Or otherwise, what is that length? Remember, guys, from 2 points, it could be a point there and another point over there. So we want to know what is the distance or the length between those 2 points. In real life, when you'll be studying, it could be engineering or whatever that you could be studying, guys. This could be a reservoir, and this could be a certain area. It could be a warehouse, it could be a tank or whatever, guys. So let's say this is point F. So you might need to know the distance from there up to there, so that you can tell the client that we will need a pipe of this long. So a quantity surveyor will say, okay, a pipe costs so much per meter. Then if you know the total distance, then you can calculate how much money is needed for you to purchase that pipe for your client. So don't worry that much about that. That's when you are in the workplace, you might be applying such knowledge. So guys, remember, could be that point and that point. When we talk about the distance or the length, we want to know what is the length or the distance from one point to another. The reason why I'm doing this, guys, is so that you are aware that in this case we are dealing with 2 points. So in short, let's just refer to those points as point 1 and point 2, as point 1 and point 2, or point 1, point 2. It doesn't matter whether you take this point to be point 1, and it doesn't matter whether you take that one to be point 2. You can also do vice versa for those 2 points. Shreyas, what matters the most is that the moment we talk about the distance or the length, we are talking about 2 points. So that is the first thing that you need to understand. So now that you guys are aware that we talk about 2 points, then it means even the formula must allow us to substitute values from 2 points. Obviously, you know very well that the distance formula is actually equals to square root of, let's say, a x2 minus x1 squared plus into y2 minus y1 close squared. So can you see, guys, assuming that we've got a line, this is point A, this is point B. So obviously this is a point, Lerato. We call it a point when it's given a name by making use of a letter, which could be any letter. It can be A, B, C, D, or any letter up to Z. This is what we call a point. The moment they do this, then we call these the coordinates. Then we call these the coordinates. So that means A, it's a point. Very, very much important, ladies and gentlemen. Then this is what we call the coordinates. So that means the coordinates has got x and y value. For example, they can say point A has got the coordinates of 2 and 3. Very, very much important, ladies and gentlemen. The same applies there. This is point B, and then point B has got the coordinates, and the coordinates, we know they are represented by the x and the y value. So those coordinates, for example, it could be a 5 and 7. It doesn't really matter that much in terms of those numbers, but you just need to be aware that when we talk about the coordinates, we talk about the x and the y value. But now, can you see, guys, we've got x there, we've got x there. So to differentiate those x and the y values, we use those numbers there to say this is going to be the second x value, this is going to be the first x value, this is going to be the second y value, this is going to be the first y value. So here comes a question, but you don't need to answer or respond to this question. Sometimes some of you guys get confused in terms of which x is x2 and which one is x1. I normally say when you are given 2 points, they like using letters, which could be letter from A up to Z. So if the question says calculate the distance between point, let's say A, B, C, D, E, F, G, H, I, J, K, L. Calculate the distance or length between K, L, which means this point could be K, this point could be L. Ask yourself this question. Between letter K and letter L, which one comes first? A, B, C, D, E, F, G, H, I, J, K, L. So K comes first. So you'll find that K is given the coordinates, which could be, let's say, x is 2 and then y is 4. Then L is given the coordinates, which could be 3 and 7 as an example. So because K comes first, then you consider these coordinates to be your first values. Because L comes second, then you consider this to be your second values. What does it mean? Good people, it simply means this is going to be your x1, this is going to be your y1, this is going to be your x2, this is going to be your y2. So all you need to do is just to substitute whatever values there. What is your x2 there is 3. What is your x1 there? It's 2. There you've got your y2 is that, there you've got your y1 is that. The mistake that you are most likely to make, that's when you are given, for example, negative values. So you always make a mistake when you substitute into the formula. That's what we notice when we're at the marking center. You know, it's so painful to see a very brilliant learner following the correct mathematical procedure but substituting incorrectly. It's very, very painful. I don't want to lie. So just make sure, guys, that always, when you substitute a negative value into the formula, substitute in brackets. Very, very much important, ladies and gentlemen. Never, ever make that mistake. So, guys, I suppose what I've explained up to this point, it makes sense with regards to a distance formula. So, guys, is there someone who can just give me an indication in terms of all that I've explained was clear and understandable to everyone? Make sure after commenting, mute your mic.
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Okay,
sir.
100%. So now let's proceed. So I've explained all that I wanted to explain with regards to a distance formula. So now let's talk a little bit more about the midpoint formula. So guys, the word midpoint. Mr. Kele, midpoint, consider that mid referring to the middle point. Good people have explained to you what a point is. For example, you've got point 1 over there and you've got point 2 over there. A, B, C, D. Let's say this is point C, this is point D. Guys, notice what I'm saying. A letter represents a point. A letter represents a point, which means when you're given a problem, the moment they say point, just expect to focus on a letter when they say a point. But the moment when they say point C has got these coordinates, then you know very well that the coordinates are represented by X and Y. So you know we've got X and Y. But because we are talking about 2 points, that means you know very well that you might need to assign the second points and the first points. Very, very much important, ladies and gentlemen. So that means when we talk about the distance, we focus on 2 points. Good people, when we talk about the midpoint, we talk about 2 points. So let's see. The same approach applies. Which one is my x2? Which one is my x1? Which one is my y2? Which one is my y1? Between point point C and point D, which one comes first? C comes first. Then these are going to be my x1, y1. This is going to be my x2 and y2. So you've got a length between these 2 points. What does it mean when we talk about the midpoint formula? So the midpoint formula helps us to find a point exactly in the middle of these 2 points. So that means the moment you use a midpoint formula, it gives you that point which is exactly there in the middle. So let's say, for example, guys, is someone from your home, they buy you those long sweets. I'm not really sure of what you call those long sweets, but I'm sure you know them very well, guys. And it's yourself and your brother or your sister. So you know very well that your elder sister is going to try and rob you. How would they rob you? They might cut that sweet somewhere there and give you that piece and they take that one. So from today, guys, tell your elder brother, your elder sister to say, no, 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 no. We are not going to split it in that way. But what we're going to do is to use a midpoint formula. What will the midpoint formula do? It's going to give you the point which is actually in the middle of these 2 points. Then you will know that this is the point where we have to cut that sweet. So that means it cuts that sweet into 2 equal halves. Guys, I hope that makes sense. I had to try and find an example which will make you to never forget what we mean by the midpoint. So remember, guys, we're talking about 2 points. So that means that point in the middle, it is also going to have the coordinates. So because it's a point in the middle, let's call it M. Why M? Because it's the midpoint. So maybe it means whatever that we are going to find over there is going to be the coordinates of that middle point. Very, very much important, ladies. So now, how do we calculate the x value of the middle point? So that means you must add the first x value plus the x plus the second x value, then you cut it into half. So you add the first x value to the second x value. What do I mean when I say you then split it into half? This is what you do. Everything that you divide by 2, it's more like you're splitting it into half. Just know that. So that's how you calculate the x value of the midpoint. Very, very much important, ladies and gentlemen. So this is going to be the x value of the midpoint. How do you then calculate the y value of the midpoint? Good people, you follow the same procedure. That means it's the first y value, you add it with the second y value, then you split it into half. How do you split it into half? You divide it by 2. Very, very much. Remember, if you are given 4 as a number and you want to, let's say you are given 4 oranges and you want to split them into half, what do? You just divide by 2. That is why even there we divide by 2. Guys, if you are given a 10 rand and you want to share it with your sister or your brother, what do? You divide it by 2. Whatever that you get, it's exactly half of that. So the same principle applies here, guys. Is the total length, or is the sum of these 2 lengths, then what you do is to divide it by 2. It's going to give you the middle point. So to cut things short, I know very well that Tisha likes shortcuts. So they did this shortcut for Tisha to say when you calculate the midpoint formula, you can just say midpoint. It's actually the same thing as that. So that is why instead of having to calculate the x value and say x1 plus x2 over 2 and separately say y is equals to y1 plus y2 is equal over 2 and do whatever and write in the coordinates. Same time, they know someone like Tisha, she likes shortcuts. So they just use this formula and say m is equal, or m point m into that. Then we just substitute into that formula. You substitute the values. Let's see. For example, let's say maybe that was -2, that was 4, this was 3, and this was -1. So now you had to substitute into the midpoint formula. So be careful, guys. I said when you substitute a value which is a negative value, put it in brackets. So that means our x1, which one is our x1? Between C and D, which one comes first? It's C. So that means there we've got our first value. So that means our first x value, because it's a negative value, substitute in brackets, then say plus, what is our x2? It's 3. So it doesn't matter if it's positive, you put it in brackets, or you don't put it in brackets. But when it comes to negative, be very, very careful. Divided by 2. Why divided by 2? Because we want to split it into equal half. What about the y values? What is y1? Obviously, it's a positive number. I can just write it as 4. What about y2? It's a negative number. Write it as a negative there. So remember, we want to split it by 2. Then when you punch all of this on a calculator, it gives you the x value of the midpoint. When you punch that, it gives you the y value of the midpoint. So remember, guys, in case if you are not able to see everything within that boundary, just make sure that on your screen you click where you see this board, don't have a list of learners who are attending as a column. So just click there. I think whoever has attended is going to appear as a row. So in that way, you'll be able to see all over there. So guys, before I move on to the next part, did it make sense to all of you what I've just explained over here?
Sorry, sir,
Yes,
I
Yes,
have a
sir.
sir.
I have a question, sir. If say you only given 2 points, which is point C
Mm-hmm.
and point M, then they
Mm-hmm.
ask you to find point D. Is it possible to also use the midpoint, the midpoint formula to also find point D?
Yes. So a very good question asked, guys. It's more like a she's saying, let me just remove all of that. Then as I respond to that question, I'll be moving to the next part of our lesson. So let's see. It's more like you are saying if we have 2 plus 4 and this is equals to what is it? So you calculate both of these, you sum them, then it's equals to 6. Then you now know that your question mark is 6 because this plus this is equals to 6. So she's asking that what if they give me 2 and they say plus, but they don't tell me that, and they say this plus that is equals to 2. Can you see? So it's more like if they give you both of this and they ask you what is the answer. If you are able to calculate the answer, it means if they can give you an answer and one value there, you must be able to do a reverse in order to find that value. So your answer, Madam Speaker, has got, your question has got an answer in it. So just in case, if you are given the midpoint, so you've got a point there and a point there, you've got point A, this is 2 and 4, then they give you a midpoint there to say maybe the midpoint, as an example, guys, let's say is 3 and 6, then they don't give you a, let's say, point B over, then they just say it's X and Y. So that means because in the statement they mentioned midpoint, then it means you can only use the midpoint formula to perform calculations. Why? Because in the statement they mentioned midpoint. So what I'm doing now, guys, is just to teach you on how to climb a tree. That is what I'll be doing in today's lesson. On our upcoming lessons, that's when we'll be solving exam question paper. So that's how examiner wants to see that if I taught you how to climb a tree, are you able to get off from that tree? So a response to that question, I'm not sure if you are satisfied with my response to that question, even though I wasn't specific. But what you asked and what you suggested is 100%. Madam Speaker, I'm not sure who asked that question. Who was it? And again, did I respond to you as expected?
Yes, sir, you did.
Who was it, Baso? Okay, so
It was
guys,
better.
all right, let's now proceed. So, the next thing that I want us to talk about, guys, it's what is it? Is the gradient. That's what I want us to talk about. So, as we proceed with these lessons, guys, just make sure to make a tick if that made sense. Just make sure to make a tick if that made sense. So now we are talking about the gradient. Very, very much important, ladies and gentlemen, that you pay full attention. Guys, the gradient, what is that? The gradient is the same thing as the slope. Gradient is the same thing as the slope. So what is the slope, guys? The slope, it's those of you who are staying in those beautiful mountain view places. You know, you've got a very slopy place, then there's a mountain, guys, a very beautiful mountain there. You will know or see more of this type of landscapes when you're doing geography. So can you see, guys, if you had to walk from that point to that point over there, the slope is relatively gentle, but to walk from that point there up to that point there, can you see that slope is too steep? And by the time you get to, let's say this is point A, this is point B, point C, by the time you get to point C, you'll be very, very tired. And I'm sure you'll start feeling tired when you get to that point because of the slope is steep. So now, how do we calculate that slope? So that slope is actually a representation of the horizontal distance or length covered versus the height gained or the rise. So these two can be used to calculate the gradient. What is the other word for gradient? The gradient is the slope. What is the formula for the gradient or the slope? Is the vertical change, of which we know anything in the vertical direction in mathematics, physical sciences, we refer to that as y. Just like on a Cartesian plane, the vertical represents the y, then the horizontal x. Therefore, that means the gradient or the slope is actually the change in y over the change in x. Guys, that's simple. It's called a delta in Greek. So what does delta mean? Delta means a change. Guys, what does change mean? Change mean, for example, whatever second minus a first. So the whatever in this case is that y. So that means it's actually y2 minus y1. So can you see we've got a fraction there? So this is that fraction. So the whatever there is x. So because of change, it actually means a change, a x2 minus x1, which means this is therefore the formula for calculating the slope or the direction. Very, very much important, ladies and gentlemen. I want to make you aware of something that you should never, ever, ever, ever forget. So let's see. That means it's y2 minus y1 over x2 minus x1. So just be careful of that symbol, which means delta. You remember a delta v, a v being velocity. The whatever in this case is v. That is why you will say v2 minus v1. Otherwise, if you like, you can say v final minus v initial. Same applies for momentum and whatever. So you should be aware of this type of symbols. Like that one, it means the sum. So just be careful of the type of symbols that you're dealing with. So guys, let's say we've got a Cartesian plane. What is a Cartesian plane? A Cartesian plane is made of two lines, vertically upwards being called the y-axis and horizontally being called the x-axis. So you can only have a positive and a negative slope. So that means for a straight line that is passing through a quadrant number 1 and quadrant number 3, this is where we have what is it? A positive gradient. Remember, gradient is also represented by m, which is small letter m. So that means capital letter M, it refers to the midpoint, but small letter m, it refers to the gradient. So that means for a straight line passing through quadrant number 2 and quadrant number 4, it has got a negative gradient. So what do I mean by that? It means if you have a Cartesian plane similar to that and you have a straight line in that direction, let's say this is the graph of G, So that means when you calculate the gradient of that, it must give you a positive gradient. Very, very much important, ladies and gentlemen. But if you have a line similar to that, can you see it's in the second quadrant, fourth quadrant, you must get a negative gradient. What I like about this type of information is that when we get to a stage where we solve exam type of question papers, before we even get to the final answer, I'm going to tell you in terms of what values to expect, whether it's going to be a positive or a negative number, and again, whether it should be more than 5 or it should be less than a certain value. Reason to that is because I'm going to prepare and teach you on how to interpret, analyze the given graphs. And the first thing that you need to do is to make sure that you fully understand what is a Cartesian plane. A Cartesian plane has got the x and the y axis. We draw functions and shapes and whatever, making points on a Cartesian plane. Very, very much important, ladies and gentlemen. So that means in this case, if we have to calculate the gradients, good people, we need 2 points. So that means for the distance, for the midpoint, for the gradient, we need 2 points. Very, very much important. So along that straight line, we just need 2 points. It doesn't really matter that much in terms of whether it's a point there or a point there. As long as it's along the same line, the gradient is the same. Guys, it doesn't matter how long a line is, as long as it's a straight line. The gradient between that point and that point is the same gradient as that point and that point. Why is it so? It's because it's along the same straight line. But the moment you have a line similar to that, that means that point there, it has got the same gradient maybe as that point there, but from that point up to there, the gradient cannot be equal to that one because the slope or the steepness change. So you can see the steepness is in that angle, and then from that point it starts to change. Very, very much important that you are aware of this type of information. So I don't think there's a need for us to go deeper in terms of performing a calculation for the gradient, because obviously you remember, guys, it could be A. What is A? A is a point. A is represented by X and Y. We can also have B over there, X and Y. So you already know at this point in terms of how to decide which one is your second values and which one is your first values. Remember, guys, it doesn't matter whether you take this as your second values and this as your first values. Just make sure that you remain constant. Don't take this x as x2 and then somewhere when you substitute, you also take this as y2. So if these are your second values, all of them must be your second values. All of them must be your first values. So you can see you just need 2 points to substitute your y value, your x value, your x value. Good people, before I start to do a bit of a drawing there to explain something, would you all say all that I've explained up to this point, does it make sense to everyone?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Okay, 100%. So I just want to quickly make an explanation of something over there. So let's just make a tick on that one. So remember, guys, everything that I'm explaining now, you don't need to stick it to your head. The main function of a tutor is just to make you aware of all that you need to be aware of, or all that you need to know. Explain it up until you understand it. So when we go deeper, that's when we solve exam type of problems. So those, I'm going to show you exactly how you solve those question papers, and just make sure that you don't miss any of those lessons, because this chapter, Analytical Geometry, it's one of the easiest chapters where you should score maximum marks. So just make sure that you do not miss any of those lessons, and again you practice some more. I'm also going to give you a link where I was doing some analysis of functions. So let's say over there we've got point A, which is -2, and then we've got that over there. Let's say we have B, which is 2, and then we have no, it's also 2, so it's 2 and 2. And again, maybe I drew that line there to say we've got C, it has a point -2, -4, and again we have got D over there, which is 2 and 1. Then I have another one from there up to there, and this is point F being 3 and -3. Then we have E, which is 0 and 0. Remember, this is not drawn to scale. So how many straight lines do we have? We have 3. We have 1, 2, 3. Doesn't matter whether you say 1, 2, 3. Doesn't matter whether you take that is 1, this is 2, that is 3. So I've got some few questions over there, of which I want to make use of those questions to interpret. So the first one says, calculate or determine the distance of AB. So can you see the question says the distance between AB? You just need to know the distance formula and be able to find point A and point B on your Cartesian plane. So that means with you calculating the distance of AB, you will know the length from there up to there. It's as easy as that. So without even you having to perform some calculations, let's just quickly say, let's say we have a 1 there, a -3 there. So this is -1, -2, -3, and then maybe let's say we have 1 and 2 over there. So you can see already, because this line is a horizontal line, you can see that from there you have 1, 2, 3, 4, 5. So that means when you use the distance formula to calculate the length from A to B, it has to give you a 5. If you don't get 5, then it means something, somewhere, somehow it's wrong. So to calculate or to find the distance of a horizontal line is easy as compared to finding a distance which is on a straight line, which is at an angle, which could be that or that. So just be aware of that. So that means for this line, you cannot say the distance. You look at that and say it's whatever, 1, maybe that, 2, 3, 4, 5, and say it's 6. Why? Because this is not a horizontal line. That means you need to use the formula to calculate that straight line. So the second question was, what is the midpoint of AB? So midpoint is that point which is in the middle of point A and point B. So because I did not draw this thing to scale, it might not, or maybe let me just try to make it a little bit closer to scale. Let's say this is 1, then that is going to be a 2 over there. So already obviously it's 1, is 2 there, and this is the origin. So already you can see that a point which is between these 2 points, you have 1. Let me just do that so that I see. I want to locate a point. So if you have these 2 points, you can say 1, 1, 1, 1. So a point in between is actually somewhere there. So this is a point which is a midpoint. So already for a line which is a horizontal line, you can see already that you are expecting maybe -3 over 2 as your x value of the midpoint. Then in terms of the y value, obviously it's going to be that same point over there, which is 2. So don't stress that much about that. Always when you are asked to calculate, just use a formula, but in your mind you should have an expectation or a certain value that you're expecting. So let me move to this part of the gradient. So let's see, the gradient of CD. Where is CD? This is point C, this is point D. So the gradient, it means we want to know how steep is that line. Here comes a question. I need you guys to answer this question. Are we going to have a positive or a negative gradient for line CD?
A positive one, sir.
Positive.
100%. So we are expecting a positive gradient. So that means when you perform calculations for the gradient of CD, your final answer, you should expect a positive answer. It doesn't matter whether it's 7 over 1 over 3, 4 over whatever, but it just has to be a positive answer. Very, very much important. So obviously, or maybe can someone tell me, what will the gradient of EF be? Will it be positive or negative?
It will be negative, sir.
100%. So that means
Negative.
we are expecting a negative gradient. So now let's check in terms of the distance, guys. The distance of CD. Here comes a question. The distance of CD, is it going to be positive or negative? Remember,
Going to be positive.
Positive sign.
so
A
Positive,
positive
yeah.
sign.
so what
Okay.
about the distance of EF? Is it going to be positive or negative?
Positive sign.
Positive. Yeah.
100%. So guys, that means when we calculate the distance, always we are expecting a positive answer. But when it comes to the gradient, that's when we expect either positive or negative answer. So in terms of the midpoint, which is the middle point, let's talk about the middle point of point EF. Where's E? There's E, there's F. So guys, when calculating the midpoint of E and F, in terms of the X of the midpoint, are you expecting a positive or a negative value?
Sir, can you please repeat the question?
So the question is, in terms of the midpoint, the middle point of point E and F, when you calculate, are you expecting a negative or positive X and Y value?
Positive Y,
The
positive X
actual
value,
Positive, sir.
negative Y value.
Yeah. Negative 5.
100%.
Both
So
of them.
obviously the middle point is somewhere there by estimation. It's just the point which is in the middle of these 2 points. So the X value, you are expecting a positive X value, but for the Y value, you are expecting a negative Y value. So I'm very much happy, guys, that we are all on the same page. So I think now what we can do is to prepare to move to the next part of the lesson. But before I continue, guys, are you all happy with what I've explained up to this point?
Yes,
Yes,
sir.
sir.
Yes, sir.
If that is the
Yes, sir.
case, then we make a tick on gradient. Let's talk a little bit more about inclination of a line. So let me just remove this part to explain inclination of a line. Good people, for every new word that is being introduced in class, sorry, ask your teacher, what does that word mean? So do not be happy to continue studying while not knowing the meaning of the terminology involved in that particular chapter. So, inclination of a line, guys, we are simply talking about an angle. Listen very carefully. An angle formed with the horizontal in an anti-clockwise direction. I spoke about few things over there, guys. I spoke about an angle. I said inclination of a line. We talk about an angle formed with the horizontal. So with the horizontal. Can you see, guys? I'm just trying to unpack. I'm just trying to simplifying that word. So an angle formed with the horizontal in an anti-clockwise direction. So an anti-clockwise direction, we know it's in the opposite direction as the clock. So remember, a clock, you know a clock, guys. It has those, the longer one and the shorter one. So you know, clockwise, these things are rotating in that direction. So that is why it's called a clock, for example. So that means anything in the opposite clockwise direction, then we call it anti. So that means when we say anti, anti what? Anti-clockwise. Anti-clockwise. So that means when we talk about angle formed with the horizontal in an anti-clockwise direction, then this is all that we're talking about in that sentence. Angle, horizontal, and that direction. So what is this horizontal, guys? In mathematics, that horizontal, it refers to the x-axis, normally to the x-axis, but otherwise not necessarily only to the x-axis, but we refer to the horizontal line. So you know in mathematics that we've got the horizontal x-axis, and what else do we have, guys? We've got the vertical y-axis. What we call this thing, we call it a Cartesian plane. What do we do on a Cartesian plane? That's where we normally draw some functions or straight lines or whatever. So let's maybe, for example, just make a drawing and draw a function which is the graph of g, or because we are dealing with analytical geometry, it won't be a function, but it's just going to be a straight line between two points. Very, very much important, ladies and gentlemen. So now that we've got a straight line between 2 points, where is the angle that we are talking about? We said it is the angle formed with the horizontal in an anti-clockwise direction, which means the angle that we are talking about is that angle over there. So guys, because we know in mathematics, we can have a straight line in that direction, or otherwise, we can also have a straight line in a different direction. So, let's say, for example, we have a straight line in that direction. We've got 2 points. Let's say that was A, that was B, this is C, this is D. So, you just need to be aware of which angle is being formed as a result of that line when we talk about inclination of a line. So this is a line, and we say inclination of a line is the angle formed with the horizontal in an anti-clockwise direction. So that means it's an angle formed with the horizontal in an anti-clockwise direction. So the angle formed, it means it's that angle over there. Very, very much important lesson. So how do we calculate that angle, guys? We do know very well that we can calculate the gradient of AB. We can calculate the gradient of CD. So they say the gradient, guys, this is the same as tan angle. This is a formula that you must know, guys. It's a very simple formula to remember, because you remember this tongue, the trig ratio is that ratio of y over what is it, x. And you remember very well that also the gradient is actually change in y over change in x. So that is why there's a relationship between that trig ratio of tan and also the gradient. So they could not say gradient is equals to sine angle, because when we talk about sine, we talk about opposite and hypotenuse. Also for cos angle, we talk about adjacent and hypotenuse. So tan is the suitable trig ratio to be equated to gradient. So that means, because you said you understand how to calculate the gradient, so that means if you know the gradient of that line, I'm sure at this point in time you know that it's going to be a positive gradient. Let's say, for example, it's equals to 2. Okay, so that means if you want to know that angle for that line of inclination, you can just say a tan angle is equals to positive 2. Then you say second function of 2, a second function of tan 2. Then it's going to give you a value. The value that you get is that angle over there. And again, ladies and gentlemen, you just need to be careful in terms of what happens when you calculate a gradient which is a negative gradient. Let's say maybe it's negative 3. So when you calculate the gradient or the angle for a line which has got a negative gradient, there's a trick in that one. So that is what I want to quickly explain to you guys. So let me maybe try to use a different marker, or otherwise let me just remove all of these and explain it so that it makes perfect sense. So we are saying tan angle, it's actually equals to a gradient. You remember that gradient and slope is actually one and the same thing. So remember, guys, let's say we've got a Cartesian plane there, we've got x and we also have y. And again, let's say we've got that a line which has got 2 points. So let me just extend that to say this is that. So obviously, for this line which has got a positive gradient, we are going to have that angle formed over there. So in summary, we are saying, let's say maybe this is point A and this is point B. In summary, we are saying what is it? Tan angle is equals to the gradient of AB. And when you calculate that angle by saying angle is equals to a second function of obviously the gradient that you get when you calculate the gradient of that AB. The angle that you are going to find is going to be an acute angle. So here comes a question, guys. What do you know about an acute angle?
It's less than 90.
100%. It's an angle which is less than what is it? It's less than 90 degrees. So that means always when you calculate for an angle, let me just nicely draw that. We have the y and we have the x. Then maybe we've got a straight line, not necessarily a straight line, yes, a straight line with 2 points. Let's say a C and D. So, Madam Speaker, you are right. An acute angle is an angle which is less than 90 degrees. So it falls in the first quadrant. So that means obviously you can see there is the 90 degrees. So anything which is within that first quadrant is less than 90 degrees. So that means for a line which you know is going to have a positive gradient, the angle that is formed with that inclination is going to be an angle which is less than 90 degrees. So if you get a value which is greater than 90, then you know you made a mistake somewhere, somehow. So let's now check for this one. We already know that we are going to have a negative gradient for that line. So that means when you calculate the angle formed between gradient or between points, that remember the angle that is formed is that angle over there. So in this case, because you know that you are going to have a negative gradient, when you calculate your second function of negative gradient between the 2 points, the angle that you are going to find is going to be an obtuse angle. Guys, what do you know about an obtuse angle?
Is an angle which is less than 180 but greater than 90.
Did you hear that, guys?
Yes, sir.
Yes, sir.
Okay, so that means an obtuse angle. It's an angle which falls in the second quadrant. So when you have a negative gradient and you want to calculate that angle, the approach is different in this case. So you have to do some more calculation. So that means that angle is going to be, let's say, 180 degrees minus the obtuse angle that you get. Let's say, for example, I think quickly, let me just remove all of this. Reason to that is because I've sent these notes in the group, but I just want to make sure that I explain this so that it makes sense. Let's say, for example, just make sure you've got your calculator. And again, Lerato, can you tell us the state of the calculator? Can you remind us that important part when we deal with angles?
The calculator must always be in a degree mode.
So your calculator must always be in the degree mode. Just make sure that before you write your maths paper 2, you make sure that your calculator is in degree mode. So obviously you guys are saying we are going to have a positive gradient. Let's just assume that in this case the gradient is, let's say, positive 3/2. So let's calculate that angle. So we use that formula. It means tan of angle, it's going to be what is there's the gradient, guys. It's positive 3/2. So let's calculate the angle. But before we do that, I want to ask you guys a question. Are we expecting an angle which is an acute or an obtuse angle?
An acute one.
An acute one. So
Angle
what is
acute,
second
sir.
function of tan 3/2?
56,31.
They are saying what, 56,31. Remember to say degrees so that we know it's an angle. So that means for a positive gradient, when you perform the calculations, you are done. Can you see you get a positive angle, which is actually that one over there, being 56,31 degrees. So that's how you calculate an angle of inclination for that line. So now let's check how do we perform calculations for a for that one which is negative. So let's see and say maybe we have a Cartesian plane there, and say maybe we have that line. So the moment you start saying this is y, this is x, we know it's a Cartesian plane. So this is the angle there. Let's see, let's call it angle theta, and let's maybe assume that obviously it's going to be a negative gradient. Let's say it's negative 1 over 4. So let's calculate that angle there. So this is tan angle is equals to negative 1 over 4. So let me see. This angle, guys, according to you, is it less than or is it more than 90? By the look of things, that angle.
Less than 9.
Guys, this angle theta, by the look of things, is it less than or more than 90?
More than 9.
It's more than 90.
More than 90, sir.
100%. It's more than 90. So that means we must get an angle which is more than 90. If we do not get an angle which is more than 90, then I'm going to teach you on how to interpret that part. So it's more like you just need to be careful that whatever answer that you get, you are able to interpret it. So what is second function of that? What are you guys getting?
Negative 14,04.
So can you see, guys, the angle that we are getting, it's not more than 90, which means it cannot be that angle. So it is this side of the angle, guys. So that means this is the clockwise angle that you are getting. So that means this is the angle which is 14, 4. So what I used to do, it was just to on your calculator you just say plus 180. So it is that one to say actually that angle it's equals to 180 degrees minus that angle that you got, which is a what is it? Let me just do these so that it makes sense. So for you to get that angle theta for a line which has got a negative gradient, after you get that negative gradient or that angle which is less than 90, even though you're expecting an angle which is greater than 90, you know that that angle is that one over there. So you just have to say 180 minus that to get that angle. So what is that angle?
194,04.
194,04.
194,04 degrees. Guys, I'm very, very much happy that your response is great and in a positive way, which means as we go deeper with solving exam type of problems, you will never have any problems. So, guys, do you now allow me to move to the next phase of this lesson?
Yes, sir.
Yes.
Okay.
Can I please ask a question?
Yes.
Okay, we only add or subtract 180 when we have an obtuse angle only. When we have an acute angle, we don't add, we just leave it like that.
100%. Exactly what you said. It's 100% correct. So only when you get that negative angle as a result of a line having negative gradient, then you say 180 minus that particular angle is going to give you an angle of inclination. So can you see, guys, a negative gradient, then expect negative angle. But you know that the angle that you are actually trying to calculate. It's not an angle, a negative angle, but it's that positive angle there. Does it make sense? Who was it? Madam Speaker.
Someone,
Does
yes, sir. Thank you.
okay, 100%. So now let's move to the next part of our lesson. Guys, allow me to make a tick over there to say we are satisfied with that one. So let's see. Equation of a straight line. So I was doing a lesson for functions where I was teaching you guys grade 10s and grade 11s in terms of where the straight line formula comes from. Remember, originally, this is where a straight line formula comes from. So from there, I explained how it evolved from that to become a y is equals to mx, which is as a result of having different gradients or different slopes for a straight line. So let me just quickly give you a picture of what I'm talking about. So you have y, you have x, you have a straight line passing through the origin. So this is where a straight line comes from. But after some time, we realize that it's not always where you just have a straight line similar to that. You can have a line which is like that, or otherwise which is like that, but passing through the origin. So what I'm drawing here, it's a line which is passing through the origin. Then after some time, that's why when we say we have y is equals to mx, that's when we have these lines which I've drawn with a broken line because of different gradients. That's why on the formula we introduce that m. Then from there, we said, although we might be having different gradients of straight line, those lines can still be shifted. In which direction? Up or down. So that means a straight line which was originally passing through there, it can be shifted up and down, which means it could be somewhere there, it could be somewhere there, or otherwise, if it's in that direction, it could be somewhere there. So that means on a straight line formula, this talks about the vertical shift. If we have a straight line similar to that, and there, if it's y is equals to mx, maybe plus 5, it means it moved 1, 2, 3, 4, 5 units upwards. If there it's negative 7, it means from the origin it moved 1, 2, 3, 4, 5, 6, 7 downwards. And then I said the slope, it talks about the orientation of that particular straight line in terms of whether it's slightly steep or too steep or very, very steep, or maybe slightly steep in that direction, too steep, whatever. So I hope that makes a perfect sense. And in that lesson, I taught you guys on how to plot a straight line function. But in this case, you need to be aware and you need to know how to determine an equation of a straight line. So because we are now moving to an advanced lesson. So this is an advanced lesson or a part of our lesson in the sense that what I'm teaching now, Shriyas, Mr. Tele, Ferdinand, Sitle, and everyone else who's in grade 10, just make sure, guys, that from time to time you engage with me so that I know my learners. So I said, as this lesson is on, I'm not really able to tell in terms of who has attended the lesson, but with your voice, I'm able to tell that Lerato is on the line. So let's see, guys. You need to be aware that this is an equation of a straight line. And again, it doesn't end there. We also have this formula, which is y minus y1 is equals to m. You know, m represents the gradient minus x, x minus x1. So, Shriyas, you don't need to stress that much about this formula. especially when you're in grade 10. But when you're in grade 11, you should be understanding these two formulas. It's actually one and the same thing. It's just that it all depends on what you are given. So we normally use this one in case if you are not given the gradient. But otherwise, if you are given the gradient, then we use this one. So that means when you use this formula, that's when you must be having 2 points. Very, very much important, ladies and gentlemen. So it means there you must be having 2 points, which could be point A and point B. Then you can easily use that one. But let's say for some reason there is a straight line and they say radiant is equals to -3, and they say this is point, let's say point P is X and Y. That point is point S, for example, is 3 and -4. So because you have the gradient and 1 point, then you can use that formula. So that means you use this formula when you're given the gradient and again 1 point. I hope that makes perfect sense. So last thing that I want to quickly explain, guys, remember, you just need to be aware of all of this information. You will enjoy it when we solve exam type of problems. That's when you'll realize that these things are not really that much difficult. And again, I'm telling you, at your school, you might take 2 to 3 weeks doing this chapter. So what is nice about this type of lessons is because siyayiqala sibe siyiqeda. I'm not really sure of how to say that in Venda, but I wish I could. So kore se re se thomileng, Ferdinand Rase Feja. What we started, we finish it. So that's why I was saying this is a summary of analytical geometry. We had to study it from the start up until the beginning so that on upcoming lessons, what we do is just to solve exam type of question paper. I'm telling you guys, when you get to this chapter in your schools, you will be understanding better than everyone in your class because you've got an idea of what to expect as the teacher is teaching. And again, you are not hearing some of the things for the first time. And again, because you were taught by someone using a very complete different teaching style, then you will find it easy to understand your teacher because sometimes you just need someone different to explain these things to you. So that is why I try by all means to use a different teaching style so that you don't feel like you are at your school with your same teacher. So just make sure that whatever your teacher is teaching you, you listen very carefully because all that they will teach you guys, it is most probably to be exactly the same with what we are discussing in class. And again, because you'll be on advanced mode, don't cause a disturbance and try to show off that you fully understand these things, guys. Just nicely keep quiet, relax, and take down, write down your notes. So the notes that you'll be writing, it's something which is not mentioned in my lesson, but your teacher has mentioned it. Then on our next lesson, make sure to share with the rest of us so that we can also learn what you guys are learning at school. So good people, there's something very much important that I want us to discuss. In terms of the lines, let's say we've got a Cartesian plane, we've got the X and the Y axis. I want us to talk about the relationship between two lines on the same set of axes. So we have parallel lines and again we have perpendicular lines. We know very well that these lines, for them to be parallel, it means they must have the same gradient. So that means if for this line m is equals to, obviously it's a positive number, it's positive 2. So this should also have positive 2 gradient. Then we can conclude to say the gradient of the graph of G and the graph of F, these two lines are parallel to each other. So that means if gradient number 1 is equals to gradient number 2, then it means 1 and 2 are parallel lines, which means that line and this line are parallel. But now, what if we've got another line which is crossing that one, and the angle formed between these two lines is a 90-degree angle? If it's a 90-degree angle, then it means this line and that line are perpendicular to each other. So how do we represent perpendicular lines? So I've just represented parallel lines to say the gradient of that must be equal to the gradient of that. But in terms of lines which are perpendicular to each other, they form a 90-degree angle. So that means the gradient of that first line, when you multiply it with the gradient of that second line, the answer is -1. So this is how you determine if the two lines are perpendicular to each other. So that means normally in exam what they do, they give you these 2 points, let's say point A and point B. Then from there, they say, let's say maybe this is C and this is, that point there is D. So examiner tries to be smart to say, give us the gradient of CD provided CD and AD are perpendicular to each other. So because you are not aware of this information, you are going to stress the whole day. So for someone who has attended a similar to this one, they will know very well that if I can find the gradient of line AB, then I can use this formula because I will know that gradient. Then I know when I multiply it with the same gradient is equals to -1. Then for you to determine that gradient, you just say -1, you divide by M1 so that it cancels, then you know the gradient of M2, which is that line. But you will understand this better as we proceed with as we solve exam type of questions. Guys, we are just remaining with a few minutes to get to the end of our lesson for today. But would you allow me to make a tick over there, or is there someone who's got a question?
No questions, sir.
No questions, sir.
Okay, guys, I thank you very, very much for being in full control of your mute button. In today's lesson, we haven't really got that much of disturbance in terms of the mics being unmuted. So there's that third image that I sent in the group, which is application 2, quadrilateral. So I think I'm going to be teaching you all of that while solving exam type of questions. So this is what I'm going to do, guys. You remember, Shriyas, we did our lesson yesterday. So what I'm going to do is just to give you your homework. So I'm just going to give you 3 functions to plot. So it doesn't really matter in terms of when you do it. You can still give me any time before, let's say, Friday. So that means you've got the whole week to do it. It won't be that much difficult. Secondly, for grade 11 and grade 12 learners, what I'm going to do is to share a link which has got the question paper that I was interpreting for analytical geometry. So 2 things. You can either try to work out that particular question paper, or otherwise you can watch as I analyze those questions. So you can just watch those lessons in preparation for when we'll be doing a lesson. So I just want us to apply that image that I sent in the group, which is application to quadrilateral. I want to show you how to use it. And again, I'll quickly take you through what is happening over there, because it might be a bit confusing for some of you guys. So I think on our next lesson, we'll quickly browse through all of that, and then from there, we'll just do one question. Then throughout the week, we'll be doing exam questions for grade 11 and grade 12. And most importantly, guys, via inbox, you can just send me questions related to analytical geometry. So just one question per person. From there, I'm just going to choose those questions which covers everything, so that we know that we do questions which are different, such that we cover all that you need to know for exam. So it doesn't help to do one question paper which has got questions which are almost the same. So we want different questions which has got different types of questions. And remember, guys, do not send me via inbox, whether on WhatsApp or Telegram, your homework, classwork, project, or whatever. What I do, guys, is to teach you on how to solve these things. Because if I help you with your schoolwork, you will get 100%, and your teacher will think you fully understand. They won't teach you further, and come exam, I won't be there to help you. So I do not help with your homework, classwork, project, assignment, or whatever. I want to teach you how to catch a fish yourself. Very, very much important, ladies and gentlemen. So guys, this brings us to the end of our lesson for today. My name is Desmond, and I'm out.
Thank you, sir. Bye, sir.
Thank you, Bye, sir.
Uh,
Thank you, sir. Good night.
Bye.